So hello everyone. This is weekly Creative Tuesdays meetup. Māris and Andra is on a vacation, so I will be hosting this week's meetup. My name is Māris Šinka. I think you all probably know me by now. I'm the head of 3D Concrete Printing Scientific Laboratory at the Riga Technical University. And today's meetup is about preparing your models for concrete 3D printing. Our idea was that by now you have already gotten your plastic 3D models ready, and we could try to with your help we could choose some part of your objects to be printed. I cannot guarantee that we will print all of the teams, but okay, maybe there are all of the teams are here, but we'll see. First, I think we can try to do first come first served. So those who will send in their models earlier probably have a greater chance to get theirs printed in concrete. So how I see today, we could go through your posters in a Miro board and try to find the pieces that we could print. Let's see. Okay. I think most of the teams are here. We can go in the order that you are here in this list. Is there anybody from only today or no? Because I don't know everybody by their names, but I think no. Okay, which is the next team that is here, like 4 a.m.? Is there anybody here from 4 a.m.?
Some of us are here, but we would like to maybe not be first because our modeler and guy who would be 3D modeling the prints is not here yet.
But he will be.
He will be, yeah.
Yeah. Okay. We can skip you right now. That's not a problem. Let's go with Fra. F-R-A. Is there anybody here? Okay. We will think what we can do with the teams that are not here today present. I don't know. Maybe we can somehow get the information. Because, okay, yeah, for this team, I would say if you would make this object, it would be, we could try to print this one if it fits our printer geometry, but I don't know. That's the question. That's a key question to some of the teams definitely here, which are the elements that can be printed on the parameters that we have on a printer. Could be interesting to print some of those structures, but yeah, I think they are working on a different model, so we'll see. We have to take into account what Fabian from Perry also told here. Definitely, that was not the thing that I was taking into account the slump. In this case, that we have these stacked objects, slump of the lowest objects will play some role. So that could be some problem. But yeah. Next one is Riyar, and I hear Arthur that you are here because your mic is on. Yes. So there are somebody from Riyar here, correct?
Yes. Reinis and I think Arthur's also.
Yeah,
So,
I heard
hey,
Arthur,
Māri.
definitely. Yeah, yeah. Hey, okay. I saw that there were some. You already sent me the email. The idea that you would like to try to print some kind of cylinders. I don't know. You can actually maybe share the screen if you need to show your idea, so I understand it better.
I
Because
mean,
you wanted to
yeah,
check the connections.
yeah, sorry. So at the moment, I can't share the screen, but your screen is fine also.
Okay.
So our idea about the cylinders was that, well, it could represent like the tip of the finger or some part of the finger. So we can just like test how we can connect the concrete parts together. But I mean, yeah, the specific detail is just, you know, the basic cylinder, or maybe, yeah, if you scroll to the scheme on the left side, yeah. So we split the hand in these lengths so that we can like print it so it fits into the 1 meter, 1.2 meter. So if we want the hand to be around like these 3.8 meters, so this would be the way. And yeah, the idea about from the cylinders was to like create smaller forms and just test the together fitting of the elements.
That's definitely, yeah, that could definitely work, that you could show that it is possible to connect them. So the idea would be that we print some layers like of the cylinder, then we put in the bolts, probably. Yes, and then we continue to print, and the same for the I guess second cylinder, and then we need some element to join it together.
Yes, correct.
Yes.
Correct. So we can try out different ideas there.
Yeah, definitely. Well, so far I don't see any problems because it's not quite specified what, like, okay, like what kind of bolts, what kind of this will be, steel plate. I don't know how it will. Yeah.
Oh, sorry about the noise pollution before, a bit, but still, yeah, the main purpose which we are wondering and considering to print out is to understand those penetration requirements for connecting, because those like cylindric forms are uneven, like not plain. Not like straightforward plane, but it's not straight edges. So it's in a way curved. So we are thinking to just understand how those bolts and how those plates should be perforated to connect them together. So most probably there should be not like just holes, but maybe more like elliptical shape, so that we can just adjust those connections for the bolts.
And also what Fabian said last meeting, that if we have, for example, here that you can see the hand splits in two and there's a straight edge between, so straight surface, the connection points wouldn't be straight because the printer can't print like 90-degree edges. So the hand would have these edges like curvature in.
Yeah, this is not, well, this is not the this is not the best place, because you would print like this, and then you would like to stop here, and then it will be like, yeah, this definitely will not be straight. Well,
but
probably,
still.
but no, and here is like, we need to think about it, because also what we saw, for example, in the lecture, and what we can because I haven't done it like that, but it is possible to not to polish, but we can like try to make it smooth, because I don't see actually any other choice. Or for example, if I would print this one, it's like, for example, 1 meter tall, I would put some, I don't know, 1 meter high, like maybe just a plywood, so the print ends at the plywood, and so the print itself is not like a round edge, but it's just attaches to the plywood. But as the plywood is like with oil, so I can later on remove it, and we have a straight line here. So I think I would try to make this, because if you don't have a straight line here, you have a problem here. How this will look ugly, and it's maybe even impossible to connect normally. Here, when it's like a top edge of the printer, so it's like a horizontal print, I cannot put a plywood. Okay, I can try to smoothen it, but all my smoothing can help this slump. So that's a problem that might be a problem in this case. But your object is so large that we won't test it in full scale, so we'll not be able to know it exactly. But the idea is that, for example, if I print this object, it will not be like the full size. It will be like 2 centimeters lower. It's a good estimate, like a optimistic estimate.
Okay.
Maybe even lower. If I have here, actually there is no problem, because whatever what height these fingers attach. But if I have some overlaps or something like here, you understand, if this is lower, then the geometry does not quite will fit, like this curved line will look like somewhat strange. But that's let's say it like this, that's a problem of the material and our print path, and not something that you can change right now. So we don't actually take that into account. That, well, we say that there is no, we will need to figure it out, but we are not dealing with it right now. So and these edges, I would say that you have to be optimistic and say we will either smoothen it, which is not a problem if I print it in this way. But actually, the plywood mold idea, I think, is very okay. You will get a straight. You can even, as it's actually maybe even better, because in that mold, I can if you have a mold and you put some holes in it and put your screws in the exact positions where they need to be, but they are like with some soft elements fixed in this plywood, so they will be printed inside the element, and then you can just remove it and the screw stays inside of your element. So actually, this might even help to position your screws correctly. Maybe even we need something like that. So because that would be our question, how to position these screws correctly so they are in the right places. But yeah, maybe we are maybe wasting too much time on this. So the idea is, yes, we can try this. Yes, we can print cylinders, but I definitely don't have anything on hand right now, like what to put inside here. What could be this metal plate? What I have is, yeah.
Yeah, the idea was to put the screws in, and the screws we can basically get somewhere in depot, or it's not a problem. But the metal plate, the idea was once the screws are fitted inside, once the concrete cures, then we can take like this plate, then we can measure and then drill holes and then put it on top there. So we don't need to we can do it after that. That was the plan.
Okay, but even then actually all I need is the screws.
Okay.
And the place where you more or less want it, because maybe you are correct right now. We right now don't need to think like exact position where the screws need to be. We will just put them inside, and you will make the plate afterwards, so you understand if it works or not. Yeah.
Yes.
So okay. Yes. Yeah. Okay, we can do it like that. So waiting for the screw delivery.
Perfect.
Okay. Probably I will ask Andra to make some chat for your. Well, probably all the teams will get some kind of a chat, so you can drop the, or you can if you are in FTU in Design Fabric, you can drop the screws somewhere there. I don't know which is easier for you, but okay, we can do that. But then cylinder. Yeah, I will think if I want to draw a cylinder, or I want you to make a cylinder that you would like to try to connect?
Well, it wouldn't be like a cylinder, like a extruded D shape with one straight part, straight edge, and then we can fit
then you need to like make a model of this element that you want, those two elements.
Okay.
And try not to make them too large. Don't make them too large. I don't want to print 1 meter high cylinder to just test how it connects. No.
So around like half a meter, that size.
You don't want to. I think yes, like even 30 centimeters. It's heavy. You will need to carry it. Well, if you will print half a meter, how you will carry it away? It's like
we need to train for it.
Yeah. So don't make anything huge. Don't make anything huge because it's easier for me to print several smaller elements than one. Because to print in this 1 meter, it takes a lot of time. Also, because the material does not set so quickly. I need to make some long print lines, and but just to test this attachment, it's make it like, I don't know, 25 centimeter tall elements, and it will be very good.
Okay, no problem.
Okay.
Thank you, Mari.
Okay, you're welcome.
Yeah, thank you very much.
Let's move forward. So we have. Okay, it's the next one is habitat. Is there anybody from habitat? Nope. Yeah, it would be interesting to try. Maybe we can print those just on the large. Maybe we can print those. It shows that my internet is not good. Do you hear me well? Somebody?
Yes.
Anybody? No?
Yes.
It's okay? Okay.
Now, yes.
So now, yes. Okay. So if there will be somebody from this team, I would like to, maybe we could print some of these elements and to see how they stack together. Maybe we can use the models from Māris, but we have to see how they will fit the printer, because some of the elements are quite large. But the idea is really good, that we need something in between that is softer, to join it, not with mortar, but with something more soft. So next one is crazy idea. It is Daniela.
Yes, hello,
right?
I'm here. Yeah.
Yeah, hi. How is it going with because I already we have already spoken with Daniela that some of the prints seem actually all of them seems too large for the printer, and we need to somehow understand can we actually print them?
I can show my screen.
Have you looked at it?
Yes, I can show my screen.
Yeah, try to share it. I think you can.
Now you see?
I was, it's starting to load. Yep.
Yes.
I see something there.
So now it is 14 pieces. So I think all of them can be varas iekļauties, tā pateikt.
Yeah, okay.
Jūs tagad mani redzat?
Fit inside the printer, yeah? All those pieces fits inside the printer. You think so, yeah?
But
what dimensions do you took into account for my printer?
Excuse me, I have bad internet. Can you repeat, please?
Yeah. What is the maximum size of this? Like, what is the largest element here? Like, what the size that you take into account that we can print?
I think this or this it's about 16 centimeters or 17 centimeters, but
Okay.
highest,
Well, that seems okay.
yeah, but I'm not sure about angles.
Angles, yeah.
Here, and I'm not sure about is it okay that piece is not parallel between?
That's not great now. Well, because yeah, as you understand, we need to somehow finish the printing. So, for example, the finished print, for example, on it will look like just the layer has ended, but you need like a straight line to connect two elements. So there will be, well, how do you connect those two? Okay, you can say similarly what I told previously. Maybe you can smoothen it at the very end, like you have printed the whole element and then you smoothen it. But I don't know. It might not be so easy because there will be like different lines will have been printed at different times. It's quite high, so and one problem that I see are the like end elements. They also have to be printed, and they are like a dome. And how do I print a dome?
Yeah, maybe these parts can be splitted more, and how to say, maybe them kā pudeles korķis, piemēram, to fill with concrete, yeah, so
like a bottle cap. Well, the idea is that yes, you need somehow to finish your element, and your element it's interesting form and everything, but how to finish it because it's so curved and maybe maybe there is a possibility to put something like underneath to print because there are only 4 elements, and maybe it would be possible to print like make some special like formwork to put underneath it so it doesn't collapse. So okay, well, I think at this point today we don't have to think about this element. I would. Can you split it that we have? We can. There is one element that has parallel lines. Yeah, that where your mouse is quite close. These two would be one of those would be something to be printed. Can you make it that we see only that element?
No, not.
No, not yeah.
No.
Okay, maybe a little bit. Yeah, just a little bit turn it so I can at least understand how it looks. Huh. Okay. Ta-ta-ra-ta-ra. Okay. Okay. I will mute you, Jirtja. Then you will unmute when you need to. I would suggest to start with this element. We can start with this element. Just maybe draw this element as one of a piece. As I said, you need some kind of supports inside, so it doesn't like just stand in the air. There needs some be supporting structure so I can print and then it doesn't collapse. Because it's quite hard for me to understand how it will look as a standalone element. and then you can send maybe before you work very much on the supports, how it looks just by itself. How wide is it? How wide this is? Like a seating area. Looks like some 1 meter could be. Okay, I don't hear you very well.
It's about 16. I think less than 1 meter.
Mm-hmm. Well, okay, let's do it like this. Try to start with this one element. Send me the how the model looks it like before you do anything further, and then with dimensions to understand the dimensions. Yeah, what's the x, y, and z sizes, and then we can understand if we can print it, and maybe we need to split some half of it. Maybe it's better to put it even. Yeah, I would actually say a half of this element would be even better, because then I could definitely think of printing it. If I would, yeah. So this is how it looked. So that was some kind of somewhere here that element was. Yeah. So it would be. It's like a 60 centimeter wide element. Half of this chair, that would be actually quite okay for printing. To testing, yeah, because I probably won't go for 1 meter high element testing here. So yeah, let's try somewhere here, the same as you had. Maybe just take a little bit not so wide. As I said, yeah, 60 centimeters. So if we print, then somebody can sit on it, and then yeah.
And I have last question.
Yeah.
Can we something metal input? Use something metal, for example, metal assets, like for building. Place it between layers. For example, you know what I mean?
Armature, like a steel rebar, or like really a mesh, or
I can show one video.
Okay, yeah, you can quickly.
Yeah. Just one moment.
Okay, I see the picture. Will you roll it, the video, or just?
You see my screen?
Yeah, I see the picture, but I don't see the video itself. But yeah.
Okay. Yeah.
I probably think it will a little bit lag. Well, I'll be honest. I'm not.
So you understand what I mean?
I understand, but I'm not 100% sure for what purposes it is here. Probably. Okay, I understand what the purpose is here. So the idea is here you can see that there is underneath the steel mesh there is nothing. It's empty. So this is a way how they print. I don't know if there is a place for probably there's a place for a window here. So this is empty. You see the black, and then you put on the mesh, and then you can print on it. So that's the way how this company and the printer. I think this looks like a Peri printer, the Cobot printer, according to Printhead. So in this way, they are making this like a overhang for the window, which is a really nice application for this, and we can do like this. But I don't see where do you think you need it in your chair?
I mean, if we print not like on the side these pieces, but print like a normal chair, and this sitting area can include this like this video šo svietlu. How to explain? Now? Okay.
Nu labi, ja noņem video, tu vari arī pastāstīt latviešu, lai mēs
Piemēram, ja
kāda ir tā doma?
Nostādināt ap šo šīs detaļas nevis tā uz sāniem.
Nu, normālā veidā, jā, bet es, jā.
Ja, piemēram, kāds.
Jā.
Ja katrs tas būtu...
Nu jā, kā printējam, tad ir kaut kāds tukšums.
Varētu iekļaut tas sežamajā vietā, jā.
Es it kā saprotu teorētiski.
Turpināt arī ar...
Jā. Sorry, ja es nedarīju, tev bišķiņ raustās internets. Well, I will say it like this. Theoretically, it is possible that we print in this direction, but this mesh will only help in where you have the seating area. Where you have this curved form that is going like the next layer, ja, tā nākamajā līmenī, kur tev iet uz augšu šis slīpums. Somebody needs to pre-mold this mesh, ja, mums vajag izlocīt to sietu, lai viņš atbilstu šai formai, tad viņam printēt virsū. Droši vien rodas jautājums, tā kā, kāda tam visam bija jēga, ja kāds ir izlocījis sietu, tad to visu var apmest tāda cementa, stiegrota cementa struktūra, viņi var arī apmest arī roku un mākslinieks uztaisīt to krēslu, tā ar roku. Tā kā šī gadījumā, yes, it is possible to print with steel, but in the scope of this object that we see here, I would say that it would be quite hard to implement the mesh in the exact places that it is not necessary and in the exact geometry that is necessary. And actually what would be the overall winnings of doing such a thing, maybe only to smoothen the surfaces. Tā kā, kāda bija tā doma, kāpēc to vajadzētu darīt?
Es gribēju pamēģināt divus paņēmienus. Tas būtu tas labākais. Es vēl tiešām nezinu. Protams, pamēģināšu gan tā izdarīt ar tiem supportiem.
No, okay. Well, yeah. Let's try to do one model with the like in the regular way, in the same way that Juris printed the chair, your chair. As I said, like just take a smaller piece of what you have here, like not so wide. Okay, you can look how it splits in those directions, but I am not very sure that we can print two pieces and to experiment with this. If I don't see any real gains in this case, if we see what we gain here, okay, yeah, but right now, okay. Think about it. If you see some advantages here, we can think about it. But right now, let the task remain for a smaller this section of a seat place where somebody. If I print, then somebody can sit there. That could be a good challenge. Yeah, and to put support there and to see if the angles are okay.
Okay.
Yeah.
Thank you.
Okay. Okay, so we can try to move forward if you, yep, thank you. 4 a.m. is ready. Oh, we will, okay, I think we can Yeah, look at 4 a.m. 4 a.m. Uh-huh. 4 a.m. What do you think if we would print, what would you suggest to print?
Well,
I hear you very, very bad. I don't hear you well. No. Coming from some, yeah.
Okay, maybe better now.
Well, it's better, but really, okay, I have max volume and I hear myself, but okay. Well, okay, I can understand what you're saying. Let's move on.
Oh, okay.
So now it's better.
Okay. So you can either look here or go upwards a bit, where you can see a diagram above the picture on the poster. You can see the diagram with the parts that on the left side under the text. Yeah. So basically, what we would print is one of these parts, and I think it would be most beneficial for us to test a piece that has the most angle as of now, to see how it performs. But since the final thing will be split up in these pieces, then I think for now, one of them to be printed would be good enough.
But these are two elements, correct? It's like this and this, yeah? Okay. Because I understand the idea that you want to test the angle. I see that this is quite high angle. I don't know. This is really 20%, 20 degrees only. I don't think so. Is it more?
Yeah, it might have been changed.
I think no. Yeah, I think that I cannot print this one. Actually, I cannot. Without any real support here, if we would try to print, there would need some support from because these elements we print them on side, correct? Like we put them on side and then we print them. Yeah. Then and you said that you will try to make this one line straighter, as I remember. No, you will change the curvature.
Yeah, here we go.
Hello, can I share? Okay, I will show updated version of this model because middle part in the blueprint wasn't changed.
Yeah.
Okay. Okay.
Nice.
There is, if you see, you see.
Yep.
Yeah, we changed this middle section, and now it's definitely less degree in this angle. Probably we still need to change a little bit here angle because we measure it and there was like 27 degrees. And
definitely. Well, you must understand that those 20 degrees. Yeah, let's say it like this. It was not on a purpose that you will take 20 degrees and will make maximum height of the object that has 20 degrees. Well, we will be. You can of course stick with the 20 degrees, but as I would say, it's not that the printer has been tested for every object and at 20 degrees, like every object can be printed. But so less angle is better for me. Okay, more angle is better for your creativity, like the object, how it looks. So yeah, if it's possible, get it lower. If it's not, then yeah, you will leave it, and we will need to think it afterwards. But right now we could choose some two elements that doesn't have these quite high angles, that has like a, maybe that is also somewhat resembles a chair if we print them only two of those elements. It could be this middle section, and I would say also nothing higher than 60 centimeters.
Wait, can I share another screen?
Yeah.
I want to show the details split.
Yeah.
Okay, I will show it, but they're take in mind that this middle section in this model are not updated yet.
Yeah.
Okay. Okay, can you see? This middle section not updated. Yeah. I would suggest to test like 4 parts, because to test out also the connection, because for example, here is those flower pots, and they will be printed in different direction, and maybe it would be better to like test those 2 parts, or maybe one of those flower pot parts and 2 of those like for example those 3 parts or 4 parts, and test out connection angles and how it looks, something like that.
Yeah. Well, connection. How did you think it would be? We would connect them.
We will screw together with nuts and bolts.
Okay. Who will make somebody will make holes in it? Yeah.
It could those holes can be made in mid print.
Yeah. Not very easy, but okay. Large holes, maybe large holes, so we can try to. Nuts. Yeah, bolts. That would be interesting.
Why?
You have to understand, because the idea is like this. Right now, I'm thinking how to print all those objects. It's quite hard for me to think. Okay, so yeah, as with the team Riyar, they are supplying me with the screws. I say, okay, I can try to insert them. If you say that we need to put some opening, I can say, okay, I can put some opening. But if you say I need to screw them together, I'm saying I don't know how.
Okay, but in this laboratory, you will be only one who take the model and stay there and print those things, or we can assist.
There are more. Yeah, of course you can. Yeah, well, more or less. In theory, you could assist. In practice, I don't know. We could try, but also 8 teams. If everybody wants to assist, it's quite a lot of time.
I mean, we can drill afterward, because if it's a good drill, then it's not that big of the problem to drill the concrete through.
Well, it's quite, yeah, it is possible. It's a little bit brittle. Concrete is brittle. I am thinking about cracks. You will get definitely cracks. It would help with a small drill, maybe.
Or we can get like a stamp in it, place to drill. It will be thinner, but afterwards when we drill, it will that doesn't take as much force, and after printing it will better hold up, and
well, definitely. Actually, probably the best idea would be to make this hole right after printing, when it's starting to set.
Yes.
So then it's possible to make the hole. Need to think how, where. Okay, how big is this 3 elements? What's the size?
I think it's
what's the width? The width I'm interested here because
width.
Like what they are like in this direction. If I would print, okay, if I would print it, what's the height? Okay, what's the height if I would print it?
Less than 40 centimeters.
This element, yeah.
Yes.
Okay, can you show it from the side? Yeah, 40 centimeters, like 40 centimeters. Maybe rotate it so I had a little bit like where I would sit. I want to understand. No, just the whole element. No, the whole 3 elements. So I understand that like proportionally the geometry. So
no, it will be seated like this, like.
Yeah. Okay, so I can sit here. Okay, so the height in this direction probably is what the seating area height is like some 50. Okay, then it could be of some 40 centimeters. Okay. Then
it's I think it's 35 because we will add the wooden elements because it will be more comfortable to sit on.
Okay. Labi. We can. For now, I would say okay. We can choose these 3 elements. It is maybe a lot, but I don't maybe understand how because if you have those large elements, somebody needs to carry them. Who will carry them away? and I don't want to print because I was experimenting with last team's Davis, one of the elements, and they waited. No, the theoretical experiment, and they weighted like 90 kilograms, and I don't want to carry 90 kilograms.
Okay. For the test print, we can just make it thinner. Like 20, like that. 30, 20 centimeters.
Well, but yeah. But then you cannot. Yeah, it would be best if we could sit on it. Probably, it will be so thin. Like if it is 40, then it's something that you can actually imagine that you are sitting on.
Yes.
If it is, yeah, because I don't have my meter here. So you're saying it's only 40 centimeters. Yeah, you can sit on 40 centimeters to try to understand how you feel on it. Okay. But if it is 40, leave it at 40. Yeah. Okay. Leave it at 40. And then yeah, draw those. And probably you will also, I don't know, did you had some supports inside of it? So, well, to understand how it doesn't break
no,
in any direction.
There will be
you need something inside.
Outer shell and outer shell, and we suggest to print it. It's only way to print like this all the parts.
Yeah. Okay. And then when you will okay, and then you will put it on this side, and so it doesn't collapse in the middle. You need some kind of support maybe in the middle part. Oh, can I draw here? I think I somehow can draw here but I'm not sure how. No. Video. Reactions. No, I cannot draw here. If your element is totally whole, there is some forces that if somebody is if somebody very heavy person sits on the top, think of it as a tube. Think of like take a paper tube in your hand and imagine a heavy person sitting on it. It will happen the same with the concrete. Yep, there's something there. You need something there.
Okay.
Yeah.
At least there. No, the same. No. Concrete. The same. You just need to. No.
Oh yeah.
I don't. Yeah. No. I don't want any. No? I don't want any extra elements. We need just more concrete here.
But it will be. This support structure can be made in the slicer.
Yeah, you can make it, of course, but
no. It's not in the 3D modeling software, but in the slicer where you slice it. You just slice it with like, I don't know how much percentage it will be, but
like a whole mesh,
like some kind
yeah, I understand. Generic this filling. I'm not sure that I want if we would use it here. The idea is we need something in the middle. I don't need something in other directions. So if you put if I put the generic slicing fill here, I get a lot of, then the element will weigh a lot.
Yes.
Because it will be full of concrete. I don't want that.
Okay.
But we could go with for example this one support, or for example something similar to this, or in like a triangle. So it maybe even this straight line was, maybe it's okay for this test. I would say this straight line was okay. What somebody was drawing there. So just straight line because.
Yeah.
But like normally when you slice it like without anything, that means there will be like only shell, but that means I should remodel it as it already is a shell and put inside the support. And when you slice it,
probably yes,
it will goes like, I don't know, twice or one time. That I need to know the thickness of this slicing.
Yeah, I understand the idea. Yeah, how to make your print pass so it is logical here. Not well, yeah. If it would like an extra element, it would not be the best. That's bad, because that is what I wanted Juris for already have been printed, and it's a pity that he is not being able to be here today. I don't know yet, because I don't want it to be like a two shells. It would be too much material. Just the middle section.
I can just model it empty model and put like very thin sheet, and this thin sheet will generate as the one line.
No, that will definitely help. I am thinking about the print pass, so it will do the shell, and then it stops to go every layer to print this one line, and then it has to restart. I'm thinking maybe how to make it a little bit optimized, but I don't know if it is possible here. Yeah. Maybe, yeah, to fill with something else. I don't know. I because I'm looking at it, I think we need it, but
we can
maybe we don't need it.
We can insert in the three points. We can insert the pipes and fill it with concrete or something, and like it will support probably also.
Steel rebar. We can put steel rebar. Yeah. Okay, pipes. Now I will just put a steel rebar there. That could hold. Okay, do the yeah. If we would do that, let's see that. Okay, let's see about the next element. If it's actually maybe even more complicated than this one. The
which element?
Like the back support, the yellow one. The yellow one. In this case, okay. But if nobody will sit on top of it,
yes,
maybe this one will not break.
Yeah.
Okay, so in this case, we don't need any. We'll try to go without any support.
Yes, but also
okay,
it's much thinner also because the walls are supporting.
Yeah, definitely. Yeah, definitely. Here is like two walls together. It's no problem. Okay. No, maybe let's do it like this. You have these three elements: model, it in a way that we can print them. No, like do this. Yeah, because I guess you didn't have those files made for Juris because he had this like one complete element.
No, Juris just wanted to, for him, I made all separate parts, but he wanted to print it all the parts together.
Okay.
And then I especially made a model for him to.
Okay.
Print it
here,
in
yeah. Well, anyway, yeah. So if you have those three elements here that fits in, are on the right sizes. So yeah, make those printable, and let's think about the support for the bench part. Maybe it's easier to put some because anyway we need some steel support. We would need there. Maybe to put something inside and it would be easier. Let's right now do it without. In this case, do it without any concrete support.
Okay, that means it's like this, and you just need to slice it.
Well, yeah, but you have different directions probably. If I would slice it in this case, if I had.
Okay, then I just need to rotate the parts.
Rotate the part that is need to be rotated. Think about in which direction you want to start the print, end the print. Is this flower pot? Does it look like that? Yeah, because I understand there's because
it's in the new model it will be a bit different.
Because it is printed in this direction, correct? It is like in this direction. Yeah.
Yes.
Okay.
And it will be like upper part, like it will be still as a like a pipe, but there will be like there you will hang actually this plastic pot in it.
Yeah.
Because otherwise, I don't know if it'd be a good solution to just put the dirt in the.
Yeah, not the best, not the best. Definitely, actually, some So it will be just like not a cylinder, but like cylinder but square. Yeah, like it will be empty inside.
Yes, and maybe maybe it will be. But maybe this could do only in the final production. If you choose our team, then we can fill like bottom with a layer of just concrete, and it will be like more stable. I don't know. Like maybe like 3 centimeters.
Yeah.
And drill
to fill it with concrete afterwards is not a problem.
Yes.
Well, yeah. Those 3 elements will definitely will start with maximum 2 because you have anyway more than other teams have. If it's 3, I don't know. We'll see. Right now we are actually maybe it's even more elements that we will be able to print in this time scale right now. But make those 3 elements that if we are ready, then we can print them. Because height of this is probably some 60 centimeters, right? No, the purple element.
Purple, yeah, probably, yeah.
Okay. It's clear to me. We can try to put some holes to just poke a hole once it is printed, but then we need to know where to poke them and how to do that. Think about if you have seen how 3D printing works. So how do you put the hole in the exact position where you need to? So some kind of like a schablons, or something like that. How to put how to make a hole in the exact position. Maybe even maybe later. But as I said, I'm not so keen on. I have seen these elements are brittle, quite brittle. And if you usually drill concrete with a perforator, so it generates this vibration and everything cracks. It's not good.
Okay.
So So it would be best not to drill it in afterwards.
But then maybe like steel pipes put while printing and
like a cut pipe, like a just a cut pipe, and then you have a
Yes.
hole, yeah, and then
Yes.
we will print. Well, it is, yeah, but if the pipe is quite large, it will influence the print there, and there will like the material will little bit leak out. But of course, it is the place where you join the elements together, so it's not possible to see, and we can like smoothen it out once it's printed. Yeah, so maybe it's not a problem. Yeah, we could put some pipes, and then you can try to screw it together with some larger bolts.
Yes, but this pipe could be pretty small, like maybe like 2 centimeters in diameter.
Okay, but think about it. Okay, I'm printing. Where do I put the pipe? How do I know? Because it will happen quite fast. How do I know where to put the pipe? Because it just needs to hang in the air while it's print. Like, how do you know it? Like, which place it will be? At what distance? What height? You will stand with the measuring tape and like try to put it there.
It doesn't need to be that precise. It could be like in every like 30 centimeters or.
No, because you need it precise because you have an element on the opposite, like where you need to join it together.
Oh, yeah.
That's when you need it very precise. That's the problem. That's the problem with RIAR. They are thinking about. They will make large holes in the metal, so the solution always is a large washer. You have a large hole, you have even larger washer.
Yes.
Yeah. So you can. That's the problem that I am thinking about right now.
But then it can be not the pipe. It could be like pipe who is pressed down like I don't know, like
something oval shape, something like that.
Yeah, but more like square insert, and it will be like line, and then it could be easier than to know.
Yeah, but then could be. Well, I would say it like this. Think about this think about this joining. Yeah, maybe there are simpler solutions. Maybe we just need to right now, I don't know, put a mortar. Maybe, yeah. Maybe it's a too detailed problem because there will be definitely 10 more details that we need to solve in this object. Think about it. Do these 3 objects, and we can discuss, I think, this later, and maybe move on, and we can discuss this even because I will definitely will not have been printed these elements till next meetup. I'm not sure what is the next meetup, so if we need to discuss, we can discuss it because it's we have still some teams remaining. So make your model, send the model, and then think how you best way to join them.
Okay. So we will continue discuss this thing in the next meetup. Yes.
Well, the idea is that you will make your model, send the model, and you will maybe have come up with a really good idea, and that because all those are implementable, but I don't know if it's the best idea, because if you will put something large inside, then when I print, I would like for it to not to print there. If the material is printing there, that will overflow. Yeah.
Okay, but okay, I have a quick solution in the mind. When those 2 parts are printed, then you can it's still not very brittle.
Yeah. Then you can we can do something that time. Yeah. So it's still curing. So it's quite soft, but starting to cure. Okay. Yeah, we can make a hole. Just it's question where.
Okay.
So we can make a hole, but as I said, you have one element, you have a second element, and you need to know like, and those elements are not like easily, you have some bottom of them that maybe you can measure. Maybe it's even, maybe you can measure just
it's the same height. That means it's not that hard to measure it.
Maybe just to measure from the bottom of the element, just two quite large holes. We can just poke them, and then use larger metal washers to join them. Probably that would be just the simplest solution. Maybe not the solution that we would use if we would print 10 of these benches, but for now it would be, I think it's okay, and we can try to do it like that. Two holes in each element with the 40 millimeters in diameter, and then I think we will be able to get the correct. It will be in the correct place.
All right. Thank you.
Okay. Let's do it like that. Make the model. Send the model. We'll see if we can be able to print them. Yep. Let's continue.
We send it directly to your email or the 3D concrete competition one.
Actually, we haven't discussed this.
So
maybe see, I think the easiest way how to spam my WhatsApp is to make a new chat for every team, as Andra has already done for some teams, and then you will send. There is something. Maybe like that. I will talk with Andra and Matis how they want to do it.
So in the G code, you want to get the file in the G code, not in the STL or STL.
STL, because you don't have the all the parameters to split it.
Yes.
STL file.
Okay. Thank you.
Okay. Welcome. Let's continue. Let's stop sharing the Lauris screen. Thank you. Thank you to all that has remained. I think only 2 teams left, if there are nobody from some of the teams that we already went over. So it's team architects, right? Is there somebody?
Exactly. Hello.
Yeah. Hello. So these nice lines that look so nice in this model, but not so nice on 3D printed elements if we don't do them in different method. Have you thought about any changes, or are you staying with this?
Maybe there would be a little change to think about. Do we need to create the like I can show? Maybe I can try to show on your screen, like annotate. Yes.
Sorry, on my screen. You want it on my screen, yeah? Okay. Yeah.
There's nothing important actually. Like, do we need this? Like,
what? I'm actually not sure. So the idea is like, I see here like 5 lines, but the whole okay, the wall is just 1 print line, correct, or 5 print lines?
No, only 1.
Only 1.
Yeah.
Okay.
I can tell a little story. There was a thing that we just want to create the same that we see in the visualization, because without these 5 lines, we will see only the 1 contour, and it looks a little bit not like we want to in the design. But we in the same time we want to save material, and we needn't these 5 lines. This, we see the solve to this problem. It is one of the way how we do it. Like we just print in one side and turn around it and make that.
print on one side. And print on one side and turn around. Sorry, didn't get the idea.
Like we print this in another side. Like we print these 5 lines on the ground, and then just turn around, and then we get these 5 lines, only 5 lines. But there was a problem about the issue is these gaps will be in the real like 3D print of concrete.
Those gaps, I would say that those gaps, I don't know if I see the real gaps is what Mattis drew here when Fabian was. Those two where the yellow is, there will be gaps definitely, because the print doesn't end like so it's not a straight, or it's not so sharp. In the where you have shown, I think actually it will look much there will be more material than necessary, because when it will not I don't think there will be those gaps. Well, we can test it, but if that's the only reason, why you want these to eliminate these 5 lines, I would not. I don't know if those I think it will, but it will definitely, I think, look much more ugly than here, because those really sharp angle, I think there will be too much material. It's what you do in the splitting, and what you do in the G code, there's some inertia of the material. I think it will be, and you have to understand that when you print concrete, it doesn't behave like the plastic. So, for example, I don't know in this case how it looks, but like the concrete, it pulls. If it has printed something, the material pulls itself away. So in those edges, it just like pulls the material a little bit away from that edge, and it definitely doesn't stay in this sharp edge. So it will look not so great, but I think for different reasons. That's the problem. Maybe that's the solution to get rid of those 5 lines. Yes, maybe, but yeah, maybe something to test. Maybe something we need to test. We can test this element if it's very important for you.
Yeah, it's probably could be, for example, this part, it's not necessary to create this dose height. For example, you can create it's like 10 centimeters high and just create this angle, maybe in the different scale.
But you understand, if I would like, if everything is 1 line and here is 5 lines, I would just print it on, how do you suggest it would levitate in the air? Like yes. I would just print it on flip it. So when I print, this is like a first layer. These are the first layer.
Exactly. Yeah. It was meant.
Yeah. So this is like well, there will be one problem. It might not be a problem. Everything actually, if we print in that direction, then everything will look good here. But you will not be able to see 5 lines. It will be like one element and something inside, but it will join together. You will not be able to see it in this in that way.
Yeah, it's not necessary to see them. Yes, the necessary is to create the place.
No. Then well, okay. Then we can yes. Then we can print, as you said. Well, I have some issues. I would like to see how it will look, but definitely we could print this like a whole element, and then as you said, 10 layers, for example, of the element, so we don't need to print it whole. I would maybe we'll put some maybe when you draw it, maybe think draw that there is 2 layers of these 5 lines, because I think I will want to add some reinforcement here, just to put like for safety that it is there, because anyway, as you understand, this is an overhang. It needs to somehow support itself. It doesn't support itself. So I need some reinforcement here. I need at least 2 layers to put like in between. So drew this element and then yeah, 2 layers of this, and then 10 layers. Flip it over in STL file, so we just can just print it.
Okay, just in 2 layers. Okay.
Yeah, 2 layers.
A question is, do we need this? For example, if we will put there wood beams, maybe it's not necessary to spend the material to create the same as here. Like we maybe can
I don't
create
know
only
if
one.
You won't be able to see anything between the wooden beams, or how do you think? It's like the wooden deck will be so uniform that you will be won't be able to see it. I don't know. It's most from the let's say it like this, from structural point of view, it's not important. It's only from design point of view. If you need it from design point of view, then you can leave it. I don't see the materials spent here is definitely not so great. If you would suggest to fill it with the concrete, I would say, yep, that's some amount of material. But this 5 layers, this is nothing. So if you need it, we can leave it. If you don't need it, we can, of course, take it away.
So yeah, there is 2 choices: fill or not fill. Yes.
Yep. And there are no. I think the choice is you should make the choice from design point of view, not the structural, because structurally it's not important.
Yeah, maybe we just think if we will fill, maybe then we will like collect the water or something else, and beams will not dry so well or something else. This is one of the reasons. So we need to create a little slope to water take off of them, because it's good like that.
Well, actually, all the time when you actually, for all the teams that want to put some wood on top, you need something in between concrete and wood. The concrete is all the time wet. If the wood is all the time wet, there will be problems. You need some other material. Either it's some thin layer of some water resistant material. Maybe if you will put some, I don't know, something that looks similar to wood, but it's actually not wood, maybe then you don't need it, of course. But in this case, I agree with you. The less contact with concrete for the wood is better, but you will anyway have it. So okay, 1 layer, okay, it's not so great. Of course, you could leave it for 1 layer. Probably it will. From that point of view, I would say that it's better to print without those. But I don't know if it's like technically right now. I would not say it's not the most important question, but it is something to think about. Yeah, it is something to think about.
Yeah, if we could test this part, like if you will print on the concrete, maybe we could test the connection of the wood and concrete, like between them. Of course, there will be some metal detail, for example, 90 degrees, want some metal detail to connect the wood to the concrete. But we would like to see how will concrete react to the perforation, like, or something else.
As I said, I would suggest not drilling in this concrete afterwards. If you need to insert something, as you said, like a 90-degree some angle where you can screw something inside, then let us put the angle on the surface and then print on the top of it. Yeah, if it's possible. And then it would be perfectly inserted and perfectly well bonded with the concrete. Because if you put some metal elements inside because there will be no straight surface. It will be very hard to attach something. Yeah, actually you will probably just glue the wood afterwards, because I don't know. I would suggest thinking about, yeah, in that regard, that you can put it inside.
Maybe like one of the ways, like we print these parts, it's okay from the concrete, but in the end on this part we can create the wood like beam system that is connected with the, for example, some metals or something else, and then it's just put it on the top of this concrete part and just screwed in like 3 places, maybe exactly in these 5 layers or something else, like just 1, 2, 3, and that would be maybe enough. So we would like to, maybe we can test, like if we will print this, we will see the result of this angle, and then after that we have a place to try to put some screws.
I understand more or less, but there are too many lines. I a little bit didn't follow I know that there is some metal element and something needs to put above something, but you know, it's everything is orange. Maybe I need to take a charger for my laptop, and then maybe you can erase what you have drawn and explain your final idea. Okay.
Okay.
Yeah. So your idea, final idea, once again.
My idea is if we, in the real scale, when we would create this bench, I think we can print this in the concrete, like this is how we do see, and then just create near this bench the wood system, like for example the beams, who is like positioned like that, they are, for example, connected with the some metal elements there, but we can take this detail just with our hands, put it on this concrete part, and just in some places, like for example 4 places, just screw them, like for example here, 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 and here.
Okay, and then we just make those, but then we can make those places where to, like holes in the concrete we make beforehand, and then you can make in the wooden or the metal part, you can make the holes where you need to, and then there are holes in the concrete part, you don't need to drill it, and then you can attach. And then I agree with you, and you have some metal frame that you put on the top of concrete, and then the wooden part, probably so you don't have this rainwater issue. Yeah, could be like that. But probably, I don't know, for now I don't. Well, I can put, we can put some holes when we print if it's necessary. You need, maybe you need to think about. So the idea is that that you could draw that element that we spoke previously. So 2 layers of those 5 lines, and then some 10 layers, so we can flip it over and see how it looks. If you want holes in it, I think I would go without holes in the element, so it looks good. And then we can, because it's really clear that we can put the holes exact places for it. Okay, let's do it like that.
Yes, we can do it.
Okay. Then it's clear. Also,
I will take it off.
Yeah, please. So, who else is here? We have started to work on this, but I think I saw Davis. Davis, is this your team?
Yes. Hi, it's my
hi.
team. Yeah.
Yeah. We had some STL files that Juris made. Those looked something. We were not able to. We were not able to adjust it for our printer. Well, actually, for your team, it is because we have already spoken with Tavis, because I was interested in testing this structurally, but then we realized that those elements are quite large and quite heavy. I don't know if this proportion. This is tall person.
This is actual proportion. Yes.
Yeah, but it was like 90 centimeters. Yeah.
80.
80.
Yeah, and 30 okay. Or 40 centimeters high.
Okay. Well, okay. Maybe it was 90 kilograms. Yeah. 90 kilograms.
Yeah, it was 90 kilograms. So
yeah, that was too much. But anyway, with your team, we will see, because my student is contacting Juris to see if he can make it from the files that you have, or we will just draw it ourselves from the sketch, as I told. Like it will be this upper half height of the upper element, and then because I want to test it on compressive strength, like to on a real testing machine, to understand what kind of force can it withstand, and
yes.
So that for your team, I think actually maybe if you want to draw this element on your own, then it's okay. But right now, I don't see actually that you need to do it, because we have the files.
Yes, because yours made models of those elements when.
Yeah. So for your team, it's like, yeah, we are going for this. Some of the elements. I am.
Lines, and the other contour is one line.
Sorry if you said something. I didn't hear almost. Yeah.
Okay. Yours made a good adjustment to the brick. For the triangle, there's like 2 lines of concrete, and the outer perimeter is only 1 line.
Yeah, I saw that. But as I said, when we opened the files, I don't know. Maybe it was some mistake on our behalf. I don't know. Because my student, were operating with them. But if we will need something, we will ask Juris to adjust the file. As this is well, that is something that I'll in your case actually, cushion, maybe the idea is we would have if we would like print everything, I would use just like use these as bricks and a mortar, and there would be mortar in between, and in those lines in mortar, if you do like brick building nowadays with large blocks, you do, for example, you put some steel reinforcement also inside the mortar, and in this case we would just like every line would be reinforced with steel in the mortar, and that, as well as cushions, it is like spreading the load evenly amongst all this. So yes, these triangles work, but they work all together, and that's even better. So in your case, definitely, yeah, there would be some layer in between that, yeah, might not layer that would be possible to see. Would try to make it as thin as possible, but it still would be there.
Yes, that's a good idea to do that.
And that would yeah, because then you can level all your blocks and then you can reinforce them, and I think that's something that you can put in your this presentation. Yes.
Yes, perfect.
Okay, is there anybody from only Fra or Habitat? Had anybody joined? No. Or there are not so much people left. Okay. Anybody has some questions?
I have last question, please.
Yeah.
About support structure. This support layers of support structure can cross main layers or just a little bit touch it. You understand what I mean?
It should touch. Yeah. Well, if you have it shouldn't cross it, because then you will get some bumps. Yeah. You need if you have your structure, then their support is just touching. It's barely touching. Yeah, because if you will draw it as it not crosses, but if the lines touch, we will have the material overflow here, and then your design will look strange. You want it just to be near, and then it will join together, taking into account the thickness of the layer.
Okay.
Okay, so no more question. It's quite late. Thank you everybody for joining. Stay tuned for the next lecture update from Māris, and good luck to everybody. Bye.
Thank you.
Thank you.
Thank you. Bye.
Bye.